Hi, welcome back to Calculus Corner, a series where I help you understand your calculus problems. Today we're differentiating the function h of x equals the natural log of square root of b squared minus x squared over b squared plus x squared. This is a really intimidating problem, but I'm going to give it the same advice I always do. We're going to take it one step at a time. Our first step for this problem should be to write our equation in the easiest way possible. Whenever we have a square root sign, we want to change that to a power of 1/2, which is something you can do at any point. When you take the square root of something, you should write it as power of 1/2, because then the derivative of the square root of x becomes much easier to solve. All we have to do is bring down the 1/2 for the power rule and minus the first exponent there. So we're going to do 1/2 times x over 1/2 minus 1, or that would just be negative 1/2, right? And the reason we want to do this is just so that we can make this part of the derivative easier. Now, there are three main calculus formulas we're going to use for this problem. The main one is the chain rule. We have the derivative of f of g of x. This basically means that we have a function with a different function inside. You can think of this as you have one type of derivative on the outside, but a different type of derivative on the inside, which we have in our problem. What we do then is we take the derivative of the outside function, f prime, then we leave the middle alone, just regular g of x, and then multiply by the derivative of g of x, which would be g prime of x. Now, the other two rules we'll have to use is the log rule, the natural log rule, which is natural log of x equals 1 over x, and the quotient rule, which we use for fractions. The derivative of f of x over g of x is f prime times g of x minus g prime times f of x, all that divided by g of x squared. Now, let's get into how we solve it. So, what would the first step of this problem be? Well, we're going to use chain rule. Our most outside function in this problem would be the natural log. So we're going to have to start by taking the derivative of the natural log, then keep this entire middle alone, and multiply by the derivative of the middle. So when we take the derivative of the outside, that would be f of x equals natural log, right? The f function that we're thinking of is going to be the natural log in this example. That's just 1 over the g of x left alone, right? We take the derivative of the outside, we leave the middle alone. And our g of x is b squared minus x squared over b squared plus x squared, all that to the power of 1/2, or you could say square root. Now, that is the first part of the chain rule. What about the second, where we take the derivative of g of x? Well, when we think about taking this derivative, what rule do we have to use? Sadly, we have to use another chain rule. The outside function here will be the 1/2 that we're to the power of, and we'll have to use the power rule on that and bring it back down to the front. And then this middle function, we can finally actually take the derivative of. Taking that derivative, we can take down the 1/2 to the front, and then we put the exponent, subtracting it by 1, so then we end up with negative 1/2, right? And per the chain rule, we take the derivative of the outside, leave the middle alone. So we still have this b squared minus x squared over b squared plus x squared. Now, the only thing we're missing is to multiply by the derivative of this middle function, which for this instance of the chain rule will be b squared minus x squared over b squared plus x squared. We no longer have the square root around it because now we've taken care of that and we're on to our second chain rule. So for this version, g of x would be different. Let's get into how we take this derivative using the quotient rule. When we're taking this derivative, this may be confusing, because what is this b doing here? Normally when we take a derivative, we only have one of these letters in our problem. So what does the b mean, and what does it mean in terms of the x? Well, our original equation was h of x. This of x sign right here is telling us that x is going to be our variable. What does that make b? Well, because it doesn't tell us to differentiate by the b, we can assume that that is a constant variable. We can assume that that is a constant number, which means that we can treat a b squared as we would any other number when we take the derivative. So for example, if I were to just take the derivative of b squared by itself, that does not equal 2b, because we would be treating that as a variable. Instead, that would just equal 0, because it'd be the same as taking the derivative of any other number. Let's say 2. The derivative of 2 is 0, right? Now you may be asking, why do they put the square there? Well, probably just to confuse you. But we don't have to worry, we just treat it as a constant. If it helps your brain anymore, you can even say b squared equals some other variable, like c. Then we can rewrite this equation as c minus x squared over c plus x squared, with the c standing for a constant. And that will actually make this derivative much easier for us. Now, when I have a quotient rule problem, this is how I like to set it up because it minimizes the number of errors I could make. What I do is I write what f of x and g of x is, and then I write down what the derivatives are for each of those functions. That way I can reference the quotient rule here and just plug and chug these numbers in and replace them when I see them. So for example, the first thing I'm going to write down is negative 2x. Then I'm going to multiply that by g of x, which is b squared plus x squared. The information is all laid out there for me, so that way there's less chance of me making a mistake. Once we plug all that in, that comes out to this lovely equation right here. Negative 2x times b squared plus x squared minus 2x times b squared minus x squared. All of that over b squared plus x squared squared. What a fun equation. We can finally write our final answer. 1 over the square root of b squared minus x squared over b squared plus x squared times this giant chunk of numbers. 1/2 times b squared minus x squared over b squared plus x squared, all that to the power of negative 1/2, times then the derivative of this middle equation, which would be negative 2x times b squared plus x squared minus 2x times b squared minus x squared, all over b squared plus x squared squared. Wow, that was a lot. But at the end of the day, we can still do these problems with the same strategies we use for any other problem, right? We had to do a couple chain rules, and we had to treat this b like it was a constant. I'm not going to go over simplifying this because for most calculus classes, they really just want to see that you can do this kind of calculus. But if you want me to go into how to simplify this, leave a comment and I will get to it. Thank you for tuning in to another edition of Calculus Corner. Thank you for watching, like and subscribe, and if you want me to go over your problem, leave it in the comments down below. Thank you, bye.